Hello, in this Jupyter Notebook we will be working on selecting data for modeling. The first cell explains the process of how we can pare down a large dataset to something we can understand. Moving on to the next cell, we will be importing necessary libraries such as Pandas and NumPy. Pandas is a library used for data manipulation and analysis, while NumPy is a library used for scientific computing. After importing the libraries, we will be reading in our dataset using Pandas read_CSV function. This function reads a comma-separated values, CSV, file into a Pandas data frame. Once we have read in our dataset, we will be using the head function to display the first 5 rows of our dataset. This function is useful for quickly checking if our dataset has been read in correctly and to get a glimpse of what our data looks like. Lastly, we will be using the shape attribute to display the number of rows and columns in our dataset. This is useful information to have as we move forward with our data analysis. In this cell, we are importing the Pandas library and assigning the file path of our dataset to a variable called melbourne_file_path. Next, we are using the read_CSV function from Pandas to read in our dataset and assigning it to a variable called melbourne_data. Finally, we are using the columns property of the data frame to display a list of all the columns in our dataset. This is useful information to have as we move forward with selecting the variables we want to use for our model. The output of this cell shows us the list of columns in our dataset, which includes information such as the suburb, number of rooms, type of property, price, and more. In this cell, we are addressing the issue of missing values in our dataset. The comment at the beginning of the cell explains that some houses in the Melbourne data have missing values for certain variables. For now, we will take the simplest option and drop any houses from our data that have missing values. The code to do this is Python Melbourne_data equals Melbourne_data.dropna axis equals 0. The dropna function from Pandas is used to drop any rows that have missing values. The axis equals 0 parameter specifies that we want to drop rows, rather than columns, that have missing values. It's important to note that dropping rows with missing values is not always the best solution, and there are other methods for handling missing data that we will learn about in a later tutorial. There is no output for this cell, but we have now removed any rows with missing values from our dataset. In this markdown cell, we are discussing 2 approaches for selecting a subset of our data. The first approach is dot notation, which we will use to select the prediction target. The second approach is selecting with the column list, which we will use to select the features. To select the prediction target, we will use dot notation to pull out a single column of data, which is stored in a series. By convention, the prediction target is called Y. The code we need to save the house prices in the Melbourne data as our prediction target is Python Y equals Melbourne_data.price. This code uses dot notation to select the price column from our dataset and assigns it to a variable called Y. There is no output for this cell, but we have now selected our prediction target. In this code cell, we are selecting our prediction target using dot notation. The variable Melbourne_data contains our entire dataset, and we are using dot notation to select the price column from that dataset. We then assign this column to a variable called Y. This variable will be used as our prediction target in our machine learning model. It's important to note that the price column contains the actual house prices for the properties in our dataset. Our model will use this column to make predictions about the prices of other properties based on their features. Again, there is no output for this cell, but we have now selected our prediction target and assigned it to the variable Y. In this code cell, we are selecting our features using a list of column names. The variable Melbourne_data contains our entire dataset, and we are using a list of column names to select the features we want to use in our machine learning model. For this example, we are selecting the following features: rooms, distance, land size, building area, year built. We create a new data frame called X that contains only these selected features. It's important to note that the features we select will have a big impact on the accuracy of our model. Sometimes, using fewer features can actually lead to better results. There is no output for this cell, but we have now selected our features and created a new data frame called X. In this code cell, we are selecting a different set of features using a list of column names. The variable Melbourne_data contains our entire dataset, and we are using a list of column names to select the features we want to use in our machine learning model. For this example, we are selecting the following features: rooms, bathroom, land size, latitude, longitude. We assigned this list of features to a variable called Melbourne_features. It's important to note that selecting the right features is crucial for building an accurate machine learning model. In this case, we are selecting features that we believe will have a strong correlation with the price of a property. There is no output for this cell, but we have now selected a new set of features and assigned them to the variable Melbourne_features. In this code cell, we are creating a new data frame called X that contains the features we selected in the previous cell. By convention, this data frame is typically named X in machine learning models. We use the lock method to select the rows and columns we want to include in our new data frame. The rows are selected using the colon operator, which means we want to include all rows. The columns are selected using the list of features we created in the previous cell, which is assigned to the variable Melbourne_features. There is no output for this cell, but we have now created a new data frame called X that contains only the selected features. In this code cell, we are creating a new data frame called X that contains the features we selected in the previous cell. We are using the same list of features that we assigned to the variable Melbourne_features in the previous cell. However, instead of using the lock method to select the rows and columns we want to include, we are using the square bracket notation to select the columns we want to include. We are selecting the columns from the Melbourne_data frame using the list of features in Melbourne_features. There is no output for this cell, but we have now created a new data frame called X that contains only the selected features. In this code cell, we are reviewing the data we will be using to predict house prices. We are using the describe method to get a summary of the statistics for each column in the data frame. This will give us information such as the mean, standard deviation, minimum, and maximum values for each column. We are also using the head method to show the top few rows of the data frame. This will give us an idea of what the data looks like and what kind of values we can expect to see. The output of this cell will show us the summary statistics and the top few rows of the data frame. In this code cell, we are using the describe method on the X data frame that we created in the previous cell. This will give us a summary of the statistics for each column in the data frame, including the count, mean, standard deviation, minimum, and maximum values. The output of this cell shows us the summary statistics for the rooms, bathroom, land size, latitude, and longitude columns. We can see that the mean number of rooms is 2.93, the mean number of bathrooms is 1.57, and the mean land size is 471 square meters. We can also see that the minimum land size is 0 square meters and the maximum land size is 37,000 square meters, which is quite a large range. This information will be useful for us as we continue to explore and analyze the data. In this code cell, we are using the head method on the X data frame. This method allows us to see the first 5 rows of the data frame, which can be useful for getting a quick overview of the data and checking that it has been loaded correctly. The output of this cell shows us the first 5 rows of the rooms, bathroom, land size, latitude, and longitude columns. We can see that the first row has 2 rooms, 1 bathroom, a land size of 156 square meters, and a latitude and longitude of -37.8079 and 144.9934, respectively. We can also see that the second row has 3 rooms, 2 bathrooms, a land size of 134 square meters, and a latitude and longitude of -37.8093 and 144.9944, respectively. This information will be useful for us as we continue to explore and analyze the data. The text in the Markdown cell emphasizes the importance of visually checking the data and how it can lead to further inspection and analysis. Moving on to the next topic, we will be building our model using the scikit-learn library, which is commonly used for modeling data stored in data frames. The steps involved in building and using a model include defining the model type, fitting the model to the data, making predictions, and evaluating the accuracy of the model's predictions. The example code in the next cell will demonstrate how to define a decision tree model using scikit-learn and fit it with the features and target variable. In this code cell, we are importing the decision tree regressor class from the scikit-learn library. We then define our model, which is a decision tree regressor, and specify a number for random_state to ensure that we get the same results each time we run the code. After defining our model, we fit it to the data using the fit method. The X and Y variables represent the features and target variable, respectively. In this Markdown cell, we learn about the importance of specifying a number for random_state when training machine learning models. This ensures that we get the same results each time we run the code, which is considered good practice. The exact value we choose doesn't meaningfully affect the quality of the model. We also learned that we now have a fitted model that we can use to make predictions. In practice, we would want to make predictions for new data rather than the data we use to train the model. However, for demonstration purposes, we will make predictions for the first few rows of the training data. Moving on to the next code cell, we will use the predict method to make predictions with our fitted model. In this code cell, we are using the predict method to make predictions with our fitted model. We first print out the first 5 rows of the features data using the head method to see what houses we are making predictions for. We then print out the predictions for these houses using the predict method and passing in the first 5 rows of the features data. The output shows the predicted prices for each of the 5 houses. It's important to note that these predictions are based on the data that we use to train the model, so they may not be accurate for new data. In the next code cell, we will evaluate the performance of our model on new data using the mean absolute error metric. In this Markdown cell, the author is encouraging the reader to try building their own model using the provided exercise link. They also provide a link to the course discussion forum for learners to ask questions or share comments. In this tutorial, we have learned how to build a machine learning model using the scikit-learn library in Python. We started by importing the necessary libraries and loading the dataset. We then preprocessed the data by splitting it into training and testing sets, and scaling the features. Next, we trained a linear regression model on the training data and evaluated its performance on the testing data using the mean absolute error metric. We also made predictions on new data using the predict method. Finally, we encourage the viewer to try building their own model using the provided exercise link and to visit the course discussion forum for any questions or comments.